7C, we're going to look at inverse functions. Okay, and so you have in your notes there a definition of inverse functions. It's really long, it's really wordy. Let me give you the short version. Okay, the inverse is when we switch x and y. Okay, so your hint here is to switch the coordinates. All right, so if I take any function, so any equation or any set of ordered pairs or any graph, to find the inverse, I'm going to switch the x and y coordinates. So over here, my original x is -5, -2, 1, 4, 7. Those become my y values. So I switch them from x and y. And then 1, 2, 3, 4, 5, that was the y values. They become the x values. Okay, so some different ways that you might see this written as far as notation is this would be f of x. All right, and then the inverse, we would call it f -1 of x. Okay, this does not mean to multiply something by -1. This is just, or to raise it to the negative first power. This is just the notation, okay, for the inverse. So if this is the original, that is the inverse. Okay, so we're going to take that those same two sets of ordered pairs and I'm going to graph them. So I'm going to do the graph, the original, the f of x, I'm going to do that in blue. And so I would graph those ordered pairs. All right, -5, 1. Okay, so that's what it looks like with all of those original points graphed. And then I'm also going to graph the inverse on the same coordinate, and I'm just going to do that in a red color. So I'm going to do that where we switch them all. So 1, -5. All right, so there's all of those inverses. And when we look at a graph, the original function and its inverse, they are reflected across the line y equals x. All right, so like 0, 0, 1, 1, 2, 2, if I were to graph that line in there, that's the line y equals x. Okay, these two graphs are reflected over this line. Okay, meaning that they are the same distance. Okay, it's like I took this blue one and flipped it over the green line and I would end up with the red line. So that's how you can tell when you're looking at a graph if things are inverses or not, is if they are reflected over that line y equals x. So are these two functions, and are the relation and its inverse functions. Okay, remember functions is vertical line test. So if I took a straight up and down line, that it would only touch that blue line in one place, it would only touch that red line in one place, so both of these are functions. Okay, so we looked at a list of ordered pairs, and we looked at a graph, and now we're going to look at in an equation form. So if I have this equation here, y equals 2x plus 8, and I want to find the inverse, okay, what I'm going to do is switch x and y. So instead of y equals 2x plus 8, I'm going to write x equals 2y plus 8. So I just switched where x and y are, and then I solve for y. I get y by itself. Okay, so now we're going back to algebra 1. Subtract 8 from both sides, so I have x minus 8 equals 2y, and then I need to divide by 2. Sometimes you will see this written as y equals x minus 8 over 2. Sometimes they will go ahead and divide this out. So remember, this is a 1x. So if I did that, I would get y equals 1/2 x, and then -8 divided by 2 would be -4. Okay, so either one of these would be considered a correct answer, and I would count either of them as correct on a test. Okay, so examples 3 and 4, we can continue to work on those in class. It's really more of the same thing. So I want you to skip ahead a couple pages to example 5. And here is one of the biggest uses of inverse functions is remember last video we talked about composite functions. So to decide whether or not two things are inverses, what I can do is find both composites. So remember, this would be like f of -1 or f of the inverse, and this would be the inverse of f. And so we plug them into each other and find those composite functions. If they are inverses, it will simplify to just x. Both composites will simplify to just x. Okay, so the first what I'm going to do is f of the inverse. So they're saying is g the inverse of f? So what I'm going to do is I'm going to take this whole thing for g, and I'm going to plug it in to f where x is. Okay, so my f of g of x, all right, is equal to 4 minus 3 over 2 times 1/2 x plus 3 over 2. Okay, so then I need to distribute this 3/2. All right, use your calculator. Don't get freaked out by fraction math. I would get 4 minus 3/4 x minus 9/4, and then I can combine my like terms. 4 minus 9/4 is 7/4. Okay, because this does not equal x, just regular x by itself, we say no. Okay, these are not inverses. They are not inverses. If they are inverses, the two composites would simplify to just x. Okay, so let's try it with that next example there. All right, so first thing I'm going to do is f of g of n. So I am going to plug this in for n in the other equation. So that means I have -16 plus 4n plus 16 all over 4. Okay, and when I go to simplify this, I have negative on the top, -16 plus 16 is 0. So that leaves me with just 4n over 4. 4 divided by 4 is 1. So this simplifies to just n, just the variable. Okay, so far so good. It has to work both ways though. So we did f of g of n. Now we need to turn around and go the other direction and do g of f of n. So this time I'm taking this whole thing. Let me do it in a different color. I'm taking this whole thing and plugging that in for n in g. Okay, so 4 times, parentheses, -16 plus n over 4 plus 16, and then I'm going to simplify this. Okay, here I would have a 4 on the top and a 4 on the bottom, so those two 4s are going to cancel each other out. So that leaves me with -16 plus n plus 16. -16 plus 16 is 0, so that is just n. Both composites simplified to just n, just the variable. So yes, they are inverses. Okay, and that's it.